Good morning. Dear student, today we shall discuss the principle of electric motor. It was a French physicist, André Marie Ampere, who for the first time demonstrated that when a conductor carrying current is placed in a magnetic field, it experiences a force. When a conductor carrying current is placed in a magnetic field, it experiences a force. This activity is to demonstrate that when a conductor carrying current placed in a magnetic field, it experiences a force. An aluminium rod AB is suspended horizontally between the two poles of a magnet by means of two wires. The ends of these wires are connected to a battery through a switch. The magnet is placed such that the north pole is acting vertically upwards. When the key is closed and the electric current is allowed to pass through this magnet, aluminium rod, this aluminium rod is displaced from its position. It would be displaced either on the left hand side direction or on the right hand side direction. The direction of force experienced by this conductor carrying current can be determined by Fleming's left hand rule. Let me describe this activity once again. This experiment is to demonstrate that a conductor carrying current, when placed in a magnetic field, experiences a force. The direction of the force experienced by a conductor carrying current can be determined by Fleming's left hand rule. Consider an aluminium rod AB is suspended between the two poles of a magnet by means of, with the help of two wires. The ends of these two wires are connected to a battery through a key switch. If the key is closed and current is allowed to pass through the aluminium rod, the rod is displaced from its position. The rod will be displaced toward the left hand side or toward the right hand side, and the direction of the displacement will depend on the direction of the current and the direction of the magnetic field. This activity demonstrates that when a conductor carrying current is placed in a magnetic field, it experiences a force which produces motion in it. This is the principle of electric motor. Now the question arises, why this aluminium rod is displaced? Why it experiences the force? So when electric current is passed through this aluminium rod, a magnetic field is produced, and there is magnetic field of this permanent magnet, and it is due to the interaction of the two magnetic fields, a conductor carrying current and the permanent magnet, that the force is experienced by this conductor. Now let us determine the direction of the force experienced by this conductor carrying current. Consider, stretch the thumb, the first finger and the central finger of your left hand mutually at right angle to each other. Stretch thumb, first finger, central finger of the left hand mutually at right angle to each other. Stretch कर लिया आपने left thumb, first finger और central finger. Now you adjust your left hand in such a way that the first finger is in the direction of magnetic field. The central finger is in the direction of electric current. Then the thumb will point the direction of the force experienced by the conductor. अपने लेफ्ट हैंड का थंब, फर्स्ट फिंगर और सेंट्रल फिंगर को म्यूचुअली राइट एंगल पर स्ट्रेच कर लें और अपने लेफ्ट हैंड को इस तरह से एडजस्ट करें कि आपकी फर्स्ट फिंगर मैग्नेटिक फील्ड की डायरेक्शन में हो और सेंट्रल फिंगर करंट की डायरेक्शन में हो, तो थंब आपको बताएगा कि वो जो कंडक्टर है वो किस डायरेक्शन में फोर्स एक्सपीरियंस करेगा. अप्लाइंग फ्लेमिंग्स लेफ्ट हैंड रूल, यू सी the direction of the current is from A to B. So central finger is directed towards A to B. This is A, this is B. The magnetic field is directed vertically upward because the direction of the magnetic field is always from north to south. So first finger is showing the direction of magnetic field, central finger is showing the direction of the electric current. You can see the thumb is towards right hand side. So this aluminium rod will be displaced in this direction. Now if the direction of the current is changed, by changing the polarity of the battery, so now direction of the current is from B to A, not A to B. Now in this case, this aluminium rod will be displaced towards left hand side. Let's see, applying Fleming's left hand rule. The direction of the magnetic field vertically upwards. The direction of the current is B to A. Current B to A. You have changed the reverse the direction of the current, and you can see the thumb is pointing toward the left hand side. So it is Fleming's left hand rule which will help you to determine the direction of the force experienced by a conductor carrying current in a magnetic field. The force experienced by a conductor carrying current in a magnetic field is given by relation F is equal to IBL sin theta, where F is force experienced by the conductor. I is magnitude of the electric current. B is strength of magnetic field. L is length of the conductor. And theta is the angle between the direction of the current and the magnetic field. If the direction of the direction of the magnetic field and direction of the electric current is perpendicular to each other, the value of theta is 90 degree. In that case, F is equal to IBL sine 90, and the value of sine 90 is 1. Therefore, F is equal to IBL. The force experienced by a conductor carrying current in a magnetic field is maximum when the direction of the current and direction of the magnetic field is perpendicular to each other. And what would happen if the conductor and the conductor is placed parallel to the magnetic field? There will be no force experienced by the conductor carrying current in a magnetic field, though electric current is being passed through it. यदि आप इस कंडक्टर को इस मैग्नेटिक फील्ड के यानी सपोज दिस नॉर्थ पोल एंड साउथ पोल, so this is the direction of magnetic field north to south, and this is the conductor carrying current. In this case, the direction of the current and direction of magnetic field is parallel to each other. In that situation, the value of the theta will be either 180 degree or 0 degree. In both the situation, the sine 180 or sine 0 is equal to 0. Therefore, force experienced by the conductor carrying current will be 0. No force will be experienced by the conductor carrying current in a magnetic field. So, sometimes in board, the question is asked, when the force experienced by a conductor carrying current in a magnetic field maximum, and when the force experienced by a conductor carrying current in magnetic field is minimum. So the force experienced by a conductor carrying current in magnetic field will be maximum in case when the direction of the electric current is perpendicular to the direction of magnetic field. And the force experienced by a conductor carrying current in the magnetic field will be 0, will be minimum when the direction of the current and the direction of the magnetic field is parallel to each other. That's all today.